Pleasant morning to my dear students. So I hope the last class, so you understand everything. Now I am moving to continuation of the last week before the last week class, because 2 weeks back I have done my last class. So now I am moving the continuation of the topic. Actually the continuation, what is the value actually from exercise 1.1 completed. Now I am moving elementary transformation of a matrix. The topic, what is the topic? Elementary transformation of a matrix. So elementary transformation. So elementary transformation, one of 3 important steps is there. If you know the 3 steps, you will be move on whatever the questions from this topic you can able. Okay. So please listen my dear friends. So just you have to understand first 3 important points. So the first points, what is the points? The interchanging of any 2 rows and 2 columns. What is the name? The first points I have taken 3 into 3 matrix set. So A1, A2, A3, then B1, B2, B3, then C1, C2, C3. According to the condition, the first condition, interchanging of any 2 rows or column of the matrix. How to interchange? Example, R1 interchange R3 means what will happen? This is called row 1, row 2, row 3. This is called C1, C2, C3. So row 1 interchange row 3 means row 2 as it is. So this is actually row 1, row 2, row 3. So C1, C2, C3. Then row 2 as it is. So B1, B2, B3. Then A1, A2, A3. That is called the interchanging of the row. As well as how to apply the column of the term. So C1 interchange C2. C1 interchange C2. How to interchange now? C1 interchange C2. So this is called C1 C2. So C2 means A2, B2, C2. Then A1, B1, C1. Column 3 as it is. What is column actually? A3, B3, C3. This is one of the first points. Okay. Now I am moving the second points. What is the second points actually? Replacing a row. So replacing a row. This is one of the common matrix set. Okay. Replacing a row of the matrix by a non-zero scalar multiple. Non-zero scalar multiple means except 0 whatever the constant term. This is one of the common 3 into 3 matrix set. How to compare with? Okay, I will compare R2. You have to non-zero scalar multiple means I have taken a constant, that is name lambda into R2 means what will happen? Lambda into R2 means R2, R1 as it is. What is R1? A1, A2, A3. Then row 3 also as it is. What is row 3 actually? C1, C2, C3. But each and every row 2 you should be multiply. What is the non-zero scalar multiple? Lambda. So lambda into B1, then lambda into B2, then lambda into B3. This is our second of the term. Similar as well as you can compare with the column also. So column means what will happen? So column means I have taken C2, any non-zero scalar, any constant number. Okay, I have taken. So 5 into C2, what will happen? 5 into C2 means C1 as it is. What is C1? C1, A1, B1, C1. Then C3 also as it is. What is C3? A3, B3, C3. So each and every column to multiply with the constant term 5. So 5 into A true, then 5 into B true, then 5 into C true. This is compared with the column term. Okay. So now this is non-zero scalar multiple with term. The third point, what is our third point actually? Replacing a row or column, sum of the row. Sum of the row means the same example for term 3 into 3 matrix set. Sum of the row means R2 compare R2 plus lambda into R1. So R2 plus lambda into R1 means you should be compared with only row 2, row 1, row 3 as it is. What is row 1? A1, then A2, then A3. Row 3 also as it is. What is row 3? C1, C2, C3. Row 2 multiply with row 1, row 2 plus lambda into R1. The constant actually non-zero scalar multiple name lambda. Lambda means, so actually common row 2 B1, then plus lambda into R1 means A1. Next one B2 plus lambda into A2. Next term B3 plus lambda into A3. This is our sum of the term row 2 plus lambda into R1. The same constant I have taken with one number. Okay, what will happen? If I taken for the number term means C1 I have compared. Okay, C1 plus 3 into C2. What will happen? 3 into C2 means C1, C2, C3 as it is. What is C2 actually? So A2, B2, C2. Then C3, A3, B3 and C3. But C1, what is the value time? C1 gives C1 plus 3 into C2. So A1 plus 3 into C2. 3 C2 is equal to A2. So 3 A2 as well as B1, isn't it? So B1 plus 3 into B2. Next one, sorry, this is C1 plus 3 into A2 B2. There is actually definitely what the term will come? C2. Okay, this is compared with any number term, that is one of the constant. Okay, this is of the full and full the three important steps for utilizing what is our name actually elementary transformation of a matrix. Okay, the same concept it will be applied for one of the row echelon form. So row echelon form, now I am moving the one of the another one concept, important concept, row echelon form. So 2 mark or 3 mark important questions from this chapter, that is row echelon form. Listen my dear friends. Row echelon form. Row EC HELON, row echelon form. Okay, so row echelon form, there is also 3 important points is there. You can read it. It will help for you how to identify the simple concept, simple definition. What is a row echelon form? When starting the non-zero digit. So I have taken different 3 into 3 matrix set. Okay, different 3 into 3 matrix set. There is actually 3, 1, 0, 5, 2, minus 1, then 0, 0, 1 is there. Okay, next one. There is 3, 5, 2, 0, 0, then 3, 0, minus 1. Here is also, okay, 0. Okay, no need, I will write the number. Okay, 3. Just to compare with 2 different type of 3 into 3 matrix that is there. what is the constant, what is the definition of row echelon form? When starting the non-zero digit under the two term will be 0 in for comparing with the first row. First row means there is actually first row non-zero digit starting with 3, but under the two rows we need to 0, but there is only one non-zero digit, another one 0 digit, but we should be proof under the two terms we should be show 0. That is first point. Okay, that is one of the first point in row echelon form. But here definitely we can say this is not a row echelon form. But in second term, second 3 into 3 matrix, when starting the non-zero digit, there is 3 is there, non-zero digit, under the two terms will be 0. Then second points, when starting the second row of the non-zero digit, there is actually second row full and full non-zero digit. So full and full non-zero digit, already we know this is not a concept of row echelon form, but in second of the 3 into 3 matrix set we can say when starting the non-zero digit 3 started, under the term also what is the name? What is the number is there? 0 term is there. So this is one of the important term for the row echelon form concept. This is definitely each and every term will be equal, correct of the row echelon form. But starting third row, you can check it, third row we have 3 of the third element we have non-zero digit. But if you compare with the fourth term means there is automatically example for your understanding there is also 0. Definitely here also we need to show 0. Right side only we can write it any non-zero digit. If you apply, if anyone question for 1 mark, so you have to clear about it. How to identify the row echelon form concept. Okay. Each and every time left side, each and every time will be 0 term will become. Right side we can write it any non-zero digit will come. That is one of the important concept in row echelon form. Okay. I hope you have understand how to identify the row echelon form. Okay. Now there is some example also is there. Okay, first one, what is example in your book actually? 3 into 3 matrix set. 1 minus 2 0 0 0 5 0 1 0. Next term. Next term. 0 3 minus 2 5 0 0 3 2 0. So we can compare it. So first non-zero digit 1 is there. Okay, under the two term also 0. But listen my dear friends, second where they have so where started with non-zero digit 5 is there. But left side definitely we have to show non-zero digit. This is also what is the name? Not in row echelon form. Then compare with the next 3 into 3 matrix set. You can compare it. So first non-zero digit, okay, 3 is there, first row. But left side definitely we have to show no, 0 term. Then only we can say this is row echelon form. This is second term also, what is the name? Not a row echelon form. Okay, in your book some example is there. Just you have to go through, you will understand more. Okay. Now I am moving on question from this chapter. What is the question? Example 1.13. Example What is the question? Example 1.13. Reduce the matrix. What is the question? Reduce the matrix. Example 1.13. Reduce the matrix. 3 into 3 matrix set. So 3 minus 1 2 minus 6 2 4 then minus 3 1 2. By question also is to a row echelon form concept. Okay, row echelon form concept. What is the definition? Main definition, important. Okay, important definition. When starting the non-zero digit, we have the starting the non-zero digit 3 is there. So under the 2 term we should be show 0. What we have to do? R2 we should be compare. There is R2 already we have minus 6 is there. So definitely we need to compare with the positive term with R1. Then only minus 6 and plus 6 means value will be 0. So plus 2 into R1, first concept. Then second R3 gives symbol minus 3 and plus 3 will be 0. So automatically we can add it directly. R3 compare with R1. R3 plus R1. Okay, what will happen? What will happen? R1 as it is. What is R1? 3 minus 1 2. Then R2 plus 2 into R1. Minus 6 plus 2 into R1 is equal to 3. Definitely minus 6, positive 6 means 0. Next term 1 plus 2 into, there is actually 1 plus 2 into minus 1. What is the term? 1 minus 2. So value will be, question is, check it there, question. 2 into R1, isn't it? So compare with 2, there is, sorry my dear friend, there is actually 2 is there. So 2 minus 2 means value will be 0. Next time actually R2 compare with R2 means 4 plus 2 into 2. So 4 plus 2 into 2 means 4. 4 plus 4 is equal to 8. Then R3 directly minus 3 plus 3 0. 1 minus 1 0. 2 plus 2 is equal to 4. Okay. Now you have to check it. Second, where it is started non-zero digit. 8 is there. So under the term we should be show 0. What we have to do? R1, R2 as it is. So R3 we need to change. So R3 gives, there is 4 is there. So we have to show there is also 4. Then only 4 minus 4 will be 0. How to reduce the term? 1 by 2 into 8 means automatically 4 will come. Therefore, what we have to do? R3 minus 1 by 2 into R2. Listen my dear friends, R1, R2 as it is. What is R1? 3 minus 1, 2, 0, 0, 8. Then R3 already comparing with R2 means both side terms will be 0. Then what will happen? Listen my dear friend, there is R3. What is R3 actually? 4 minus 1 by 2 into R2 is equal to what is our term? 8. So 2 and 8 will be cancelled means 4. Therefore 4 minus 4 is equal to 0. This is one of the important 2 more questions. Just you have to do it your own self. Okay. After revise. Okay. Now I am moving another one question. One more next question. What is the question actually? Example 1.14. So example 1.14. Reduce some same concept, but there is 3 into 4 matrix set. So 3 into 4. So 3 into 4. Question actually 0, 3, 1, 6. Next term minus 1, 0, 2, 5, 4, 2, 00. So what we have to do? To row echelon form concept. So we have to interchange because starting the term also 0 term is there. Just we have to interchange. We have to interchange means R1 interchange R2. What will happen? R1 interchange R2 means minus 1, 0, 2, 5. Next term 0, 3, 1, 6. Again 4, 2, 0, 0. Then we have the non-zero term. Under the term we need to show 0. Already 1 0 is there. But last term we have to show 0. There is actually 4 is there. What will happen? So R3 we should be compare 4 with means R3 plus 4 into R1. So R3 plus 4 into R1 means what will happen? R1 R2 as it is. What is R1 actually? Minus 1, 0, 2, 5. Then 0, 3, 1, 6. R3 plus 4 into R1. R3 is equal to what is the value? 4 is there. Then 4 plus 4 into R1 is equal to what is the value actually? Minus 1. Next term 2 with the compare 0 means 0. Okay, anyway 0 term. First we should be compare. There is 0, here also 0. Therefore, 2 into 4 means there is 8 will come. Again 5 into 4 means 20 will come. But first 2 times there is automatically 0. 2 plus 4 into 0 means 2. Now, when starting the non-zero digit, second row 3 is there. So under the time we should be show 0. How to change it? We need to show instead of 2, 0. R2. Okay, R3 gives, there is 3 is there. So fraction term only possible. Fraction term means R3 plus 2 by 3 into R2. 2 by 3 into R2. Okay, listen my dear friend. There is both of side plus. There is minus only. Then only it will be 0. Okay, listen my dear friends. R1, R2 as it is. What is R1? Minus 1, 0, 2, 5. R2 is equal to 0, 3, 1, 6. Third row we should be compare. R3 first one 0 and 0 comparing 0 will come. Next time actually 2 minus 2 by 3 into R2 is equal to what is our R2 term actually? 3. So 3 will be cancelled. 2 minus 2 is equal to 0. Next time R3. So 8 minus 2 by 3 into 1 is there, isn't it? Next term 20 minus 2 by 3 into 6 is there. So this is what is answer actually. 3 8s are 24. 24 minus 2, 22 by 3. There is actually 22 by 3. Next term 3 and 6 2 times. So 2 into 2 4. 20 minus 4 is equal to 16. Therefore, there is fraction term is there. Fraction means if you need to fraction, what will happen? What we have to do? R3 into 3. Only row 3 multiply with 3. What will happen? R1, R2 as it is. So minus 1, 0, 2, 5. Then 0, 3, 1, 6, 0, 0. 22 by 3 means 3 cancel. 22 will come. Again 16 into 3 means value will be 48. This is our final answer for example 1.14. Okay. Now I am moving next question. Next question, that is before moving the next question, just we have to understand rank of a matrix. What is the definition? Rank of a matrix. Rank of a matrix. So rank of a matrix means first we have to check it, each and every set, how many rows and how many columns is there. Okay, just I will compare the same question for rank of a matrix. There is actually how many rows is there? There is actually 1 2 3 rows is there. How many columns is there? 1 2 3 4. How many columns is there? 4 columns is there. So how to identify the rank of a matrix? Consider the minimum. 3 into 4, which number is minimum? 3 is minimum. So definitely we can say rank maybe 3 or less than or equal to 3. So consider the minimum. There is one example set I have taken, 3 rows and 4 columns. So consider the minimum means 3 we can take it. So therefore we can say rank is equal to 3 or less than 3. Then sometimes rank not equal to 3 also. How? Just we have to compare. Compare means there is C1, C2, C3, C4. Normal, you know how to find out the determinant term. Determinant means just we have to compare C1, C2, C3. Normal comparing science conversion form. The same method. How to apply in inverse of the function. Inverse of the function means, so determinant A means minus 1. Then if you hide, if you skip row and column, minus 1 means I have taken only C1, C2, C3. Then 3 into 22. What is the answer? 6 will come. Cross multiply 0 will come. After getting the 3 time, if you get the 0 value, definitely, example, sometimes you have find out the answer, determine A is equal to 0 means each and every time compare. Then one more time also possible. C1, C3, C4 also you can compare. The next one, C1, C2, C4 also you can compare. Then C2, C3, C4. each and every 3 into 3 matrix set you should be comparing. After comparing the same answer it will be repeating means again we have to move on 2 into 2 matrix set. So 2 into 2 matrix set means answer will be rank not equal to 3. When you apply 3 into 3 matrix set, each and every time will be 0 means rank not is equal to 3. Then when you are moving 2 into 2 matrix set also sometimes 0 will come. If it 0 will come means rank definitely we can say not is equal to 2. So you have to take in only one term will be. Therefore definitely rank will be only 1. Okay, for your understanding with this example. Okay, now I am moving one question, then you will get it. More idea, okay. Rank of a matrix, one question. Find the rank each of the following matrices. First example 1.15. Example 1.15. Find the rank each of the following matrices. What is a matrix actually? 3, 2, 5, 1, 1, 2, 3, 3, 6. Okay. This is 3 into 3 matrix. We can say 3 rows and 3 columns. Okay, 3 into 3 matrix, that means consider the minimum. We can say rank 3 or less than 3. 3 or less than 3. Okay, first I have taken for simply determinant of eta. What will happen? Signs conversion. Plus minus plus means 3 into, if you skip row and column of 3 means 1 into 6. 6. Then cross multiply. 6 minus 6 is equal to 0. Next term, there is signs conversion minus 2 into, again skip row and column, 1 into 6 means 6, cross multiply 3 into 2 means minus 6, again plus 5 into 1 into 3 means 3 minus 3. So each and every term, here also 0, here also 0, here also 0. Therefore, we can say determinant A is equal to 0. Already I told you, apply the determinant term, if you have the answer with 0 means rank not is equal to 3. Rank not equal to 3. So again you should be move on 2 into 2 matrix set. So 2 into 2 matrix set means what is the 2 into 2 matrix set? Determinant A is equal to 3, 2, 1, 1. What will happen? 3 into 1, 3. Cross multiply minus 2. Therefore we can say 3 minus 2 is equal to 1. This is not equal to 0. So X is 2. Therefore definitely we can say rank is equal to how much? Rank is equal to 2. This is one of the answer. Now I am moving subdivision 2. What is the question? From example 1.15 subdivision 2, there is 3 rows and 4 columns is there. So listen carefully my dear friends, okay. Subdivision 2. So 3 rows and 4 columns. 4, 3, 1, minus 2, minus 3, minus 1, minus 2 and positive 4. Then 6, 7, minus 1, 2. So there is actually 3 rows and 4 columns. So consider the minimum means rank 3 or less than 3. Okay, I have taken one by one. C1, C2, C3. This is all C4. First I have taken with C1, C2, C3. What will happen? C1, 4, 3, 1, minus 3, minus 1, minus 2, 6, 7, minus 1. What will happen? Signs conversion plus, minus, plus. So 4 means minus 1 into minus 1, positive 1. Cross multiply means plus 14. Next term, minus 3 means minus 3 into minus 1, positive 3. Cross multiply means plus 12. Then third term, minus 3 into 7 means minus 21. Cross multiply means plus 6. Therefore 4, 1 plus 14, 15. Next term, minus 3 means 3 plus 12 is equal to 15. Last term, plus 1 into minus 21 plus 6. Therefore minus 15. You can check it. 4 into 15 means 60. The next one, minus 3 into 15 means minus 45. Last term, again Plus 1 into minus 15 means minus 15. Therefore, 60 minus 60 is equal to 0. So you have to compare next time because there is 0 is there. Again you can compare with C1, C2, C1, C2, C4. Okay, you can compare it. Here is also 0 term will come. Next you can compare with C1, C2, C1, C2, C4 you can compare it. The last time C2, C3, C4. Each and every time value will be 0, sir. You can check it for your homework, okay? You can just do it, okay? You will get it 0. Therefore, each and every time will be 0 means we can say rank not equal to 3. So, if it rank not equal to 3 means we should have to move on next step. 3 into 3 matrix set. So, 3 into 3 matrix set means what will happen? 3 into 3 matrix set means so 3 into 3 matrix set 4, 3, minus 3, minus 1. So minus 3, minus 1 means, check it there, minus 1 into 4, minus 4. Cross multiply, plus 9. Therefore, 5 will come, not equal to 0. This is exist. Therefore, we can say rank true or less than true. Otherwise, we can say directly rank is equal to 2. That is your final answer for this example 1.15. Okay. Now I am moving. The next one, what is the concept actually? 1.15 also over. Moving 1.16. So 1.16. Now I am moving 1.16. So question actually, find the rank of the following matrices which are in row echelon form. Okay, very simple. If you know the concept row echelon and the rank of the matrix term, you will get it. You will ready to attempt whatever is such a type of difficult questions. So if you need more explanation, just you have to go on the previous chapter. You will understand what is the basic concept rank of matrix and what is the basic concept of row echelon form. Just you have to revise thoroughly. You will understand. So question, find the rank of the following matrices. So first one, 2, 0, minus 7, 0, 3, 1, 0, 0, 1. So find the rank of the matrix. So this is actually, it's a row echelon form. Row echelon form concept. See, when starting the non-zero digit, okay, under the 2 term also 0. Then when starting the non-zero digit in second row, 3 is there, under the term also 0. Then when starting the non-zero digit in third row, 1 is there. So under there is nothing to row and columns. So we can say this is a correct step of row echelon form. Then we can apply how to find out the rank of the term actually. Rank actually, number of, is there any non-zero row? Each and every row non-zero row. So there is nothing to say 0 row. Therefore, rank definitely we can say 3. Rank is equal to, what is the name? What is the answer? Rank is equal to 3. But second question, what is the second question? This is actually second question. Example actually, this is 1.16. Okay. Example 1.16. Second, what is the question actually? Minus 2, positive 2, 1. Sorry, minus 1. The next term 0, 5, 1, then 0, 0 is there. So you can check it the row echelon form. When starting the non-zero digit, under the 2 term 0, then second row also 0 term is there. So each and every term will be correct. So that rank of the term, how to identify the rank of the term? So first we can check it, is there any non-zero row? Yeah, third row, 0 row. Third row, 0 row. Therefore, number of non-zero row is equal to number of non-zero row is equal to 2 only, because third row full and full 0 row. So number of non-zero row is equal to 2 means rank is equal to how much? Rank is equal to 2. Okay, now the next term, third one. What is the subdivision third actually? 6 0 minus 9 0 2 0, last two rows 0 row. So compare with row echelon form, non-zero digit under the 3 times 0, then second row also non-zero digit under the term also 0. But here number of non-zero rows is equal to only 2, because 2 rows we have 0 row only. Therefore number of non-zero row is equal to 2 means rank we can compare with any 2 into 2 matrix. Definitely 6 into 2 means 12. So 12 minus 0 means 12. Therefore A inverse exists. Therefore rank is equal to how much? Rank is equal to 2. Okay. Example 1.17. What is the question actually? Find the rank of the matrix by reducing it to a row echelon form. Example 1.17. What is the question? Find the rank of matrix 1 2 3 2 1 4 3 0 5. So first we have to take it, this is called A. Then when starting the non-zero digit under the term we should be so 0. There is actually 2 and 3 is there. So R2 compare R2 minus 2 into R1. Next term again R3 gives R3 minus, there 3 is there, so 3 into R1. So R1 as it is 1 2 3, but row 2 compare with 2 into R1. So 2 minus 2 means 0 is there. Again 0 minus 2 means minus 2 will come. 5 minus 8, because there is 2 is there. So 2 into 4 means 8. 5 minus 8 is equal to minus 3. The next term R3 minus 3 into R1. So 3 into 3 minus 3 means 0. Next term 0 minus 6, because there is 3 is there. So 0 minus 6 means minus 6. Next one 5 minus 15. So because 3 is there. Listen my dear friends, so 5 minus 3 into R1 means 3. So 5 minus 9. 5 minus 9 is equal to minus 4. Okay. So minus 4. Next one what we have to do, when starting the non-zero digit in second row minus 2 is there. So under the term we have to show 0. What we have to do, both upside minus sign is there. But if you multiply into 3 means automatically 6 will come. But we need to compare with positive sign. Then only minus 6 plus 6 will be equal to 0. So what we have to do, R3 gives R3 minus 3 into R2. Check it there. R1 as it is. What is R1 actually? 1, 2, 3. R2 actually 0, minus 2, minus 3. But R3 we have to compare. 0 and 0 compare means 0 will come. Next term minus 6 minus 3 into R2 is equal to what is our term? Minus 2. Now you can check it. Minus 6 minus into minus plus 6. So minus 6 plus 6 means will be 0. Next term minus 4 plus 3 into R2 is equal to minus 3. So definitely minus 4, 3 into 3 minus 9. So minus 4 and minus 9 is equal to what is the value actually? Minus. Last term we can check it clearly. Okay. So R2 minus 2 into R3 minus 2 into R2. So it is actually 3 into R2. Listen my dear friends. Actually there is minus 2 minus 3 minus 6 minus 4. Then we should be compared with 2 into R2, isn't it? sorry my dear friends, there is actually 3 will come. Listen my dear friends, sorry, there is actually 2 into R1, isn't it? So 2 into R1 means 1 minus 4. 1 minus 4 means minus 3 will come. Minus 3 is there, minus 3 means there actually how to change it down? There is actually minus 2 into compare. Minus 2 into R2. Okay, then will be correct now. Okay, listen my dear friends, that is my mistake. Okay, just you have to change it. This is not a 2. There is actually minus 3 will come. Now we can compare with. So minus 2, there is actually minus 2. Then comparing R2 means there is actually minus 3. Therefore, minus 6 and plus 6 means 0. The next term also minus 4. Again minus 2 into R2 is equal to what is our R2 term? What is our R2 term actually? There is actually 4. R2 actually, this is actually 4 minus 2 into 3. So 4 minus 2 into 6 means there is also minus 2. Okay, here is minus 2. Now it's correct. Okay, now we can compare minus 2 and minus 2 means, so minus 4 minus into minus positive 4. Therefore answer will be 0. Minus 4 plus 4 means value will be 0. Now it's a correct answer. Therefore we need to find out number of non-zero rows actually. How many rows? Only 2 rows is there. So only 2 rows there means how to rewrite the final answer? Rank is equal to 2. Rank is equal to 2. You can compare with 2 means what will happen? I have taken, this is 2 into 2 matrix set. So 1 into minus 2 means minus 2. Cross multiply 2 into 0 means automatically 0. So minus 2 plus 0 means minus 2. Therefore, in exist term, that is non-singular. If it non-singular means rank is equal to 2. I am moving the next question. What is the question actually? Next one, 3 rows and 4 columns. Okay, example 1.18. Example 1.18. Question, 3 rows and 4 columns. 2 minus 2 4 3 minus 3 4 minus 2 minus 1 6 2 minus 1 7. Okay, there is actually 3 rows and 4 columns. Okay, when starting a non-zero digit under the term we have to show 0. What we have to do? There is actually first there is positive 6 is there. There is minus 3. If you multiply into 2 means there is also minus 6. Then it will be easy to show the 0. So what we have to do? The R2 gives 2 into R2. So 2 into R2 means what will happen? 2 into R2 means R1 as it is 2 minus 2 4 3. Multiply 2 into minus 3 means minus 6, 4 into 2 means 8, minus 2 into 2 means minus 4, minus 1 into 2 means minus 2. Row 3 as it is. What is row 3? 6, 2, minus 1, 7. Now it will be easy. Now compare with R2 compare. There is minus sign is there. So R2 plus 3 into R1. 3 into R1 means 3 into 2, 6. So minus 6 plus 6 will be 0. Again, R3 means R3 minus 3 into R1. Compare it. R1 as it is. What is R1? 2 minus 2, 4 and 3. Next term. Listen my dear friends. R2 means minus 6 plus 3 into R1 is equal to 2. Therefore, minus 6 plus 6 will be 0. Next term, 8 plus 3 into minus 2. So 8 minus 6 is equal to positive 2. Next term, minus 4 plus 3 into, so minus 4 plus 12. Minus 4 plus 12 means positive 8. There is 8. Next term, minus 2 plus 3 into 3. So minus 2 plus 9 is equal to positive 7. So okay. Now the third row, what will happen? Third row, minus 3, 2, 8, 7. Now minus 6, 8, minus 4, minus 2. Then R2 come back 3 into R1, correct. R3 minus 3 into R1. So 0 to 8, 7. Next term. Next one, what will happen? R3. R3 is equal to 6 minus 3 into R1 is equal to 2. So again 6 minus 6 is equal to 0. Next term, 2 minus 3 into minus 2. So 2 plus 6, 8. The next term, minus 1 minus 3 into 4. So minus 12. So minus 1 minus 12 minus 13. Last term, 7 minus 3 into 3. 7 minus 9 is equal to minus 2. Okay. Now the third term, listen my dear friends. Now when starting the non-zero digit second row, 2. Under the term we have to show 0. What we have to do? 0 term means 0, 8 minus 13 minus 2. Next one, compare with 4 because there is positivity is there. We need minus 8. Then only 8 minus 8 is equal to 0 will come. What will happen? Okay, R3 gives R3 minus 4 into R2. Listen my dear friends, R1, R2 as it is 2, minus 2, 4 and 3. Next one, 0, 2, 8, 7. Third row, R3 gives R3 minus 0 with compare R2 means 0. Next term, so 8 minus 4 into R2 is equal to 2. Definitely 8 minus 8 is equal to 0. Next term, minus 13 minus 4 into R2 is equal to 8 is there, isn't it? So 8 minus 4, 8 into 4 means 32. Minus 13 minus 32. So definitely 45, isn't it? There is actually minus 45 will come, isn't it? So check it my dear friends. 8 into 4, 32. Minus 13 minus 32 minus 45. The last term actually minus 2 minus 4 into 7. So minus 4 into 7, minus 4 7s are 28. So minus 28 minus 2. Answer will be minus 30. Okay. Therefore, we have the final answer, but if you need any small number means minus 45 and minus 30. Divided by 15 means it will be come the small number. What you have to do? R3 divided by minus 15. R3, the last step. R3 compare R3 divided by minus 15. What will happen? R1 R2 as it is 2 minus 2 4 3 0 2 8 7. Then minus 45 minus 15. 45 minus minus cancel 3 times possible. Then minus 30 divided by minus 15. Minus minus cancel. 30 divided by 15 means 2 times. Okay, that is our final answer. Okay. Then after getting the answer, is there any find the rank of the matrix, isn't it? Rank of the matrix, we can say rank is equal to 3. Rank is equal to how much actually? Rank is equal to 3 because is there any 0 row? There is nothing. Each and every row number of non-zero row. Okay. So number of non-zero row is equal to 3. 3 means rank also will be equal to 3. Okay. Now I am moving. Example 1.19. So okay. Example 1.19. Okay, example 1.19. Question, show that, okay, show that 3 into 3 matrix set 3, 1, 4, then 2, 0, minus 1, then 5, 2, 1, okay. Show that first non-singular means determinant A not equal to 0, first condition. Then what we have to do? Reduce identity matrix. You know what is the meaning of identity matrix set? 1, 0, 0, then 0, 1, 0, 0, 0, 1. We have to show the two condition. Okay, first condition, non-singular. Non-singular means what will happen? What we have to do to prove the non-singular term? So determinant of A signs conversion plus minus plus, then 3 means 0 into 1 means 0, then cross multiply plus 2. Next term, minus 1 means if you skip row and column of 1 means 2 into 1, 2, 5 into minus 1, positive 5. Next term, plus 4 means 2 into 2, 4, cross multiply 0 is there. Therefore, 3, 0 plus 2 minus 1, 2 plus 5 is equal to 7. Then plus 16. Check it there. 3 into 2, 6. Again, minus 7 plus 16. So 16 plus 6 is equal to 22. 22 minus 7 is equal to 15. Therefore, determinant A is equal to 15. We have to prove non-singular, not equal to 0. First condition is clear. Now I am moving the second condition. Second condition, what we have to do? Identity term. Identity term means we have to show 3 into 3 identity matrix. Okay. Identity matrix. So first term, first step, what we have to do? First we need to show 1. Then only first diagonal term, each and every term 1. Remaining each and every term we have to show 0. That is called identity. So R1 divided by 3. R1 gives what we have to do? R1 divided by 3. What will happen? R1 divided by 3 means, so 3 by 3, 1 will come. Again 1 by 3 and 4 by 3. R2, R3 as it is. 2, 0, minus 1. Then 5, 2, 1. Okay. Second one, under the two terms we should be so 0. What we have to do? Compare with R1. So R1 gives, sorry, R2, okay. R2 minus 2 into R1. Next term, R3 gives R3 minus 5 into R1. So R1 as it is. What is our actual row 1? 1 by 3 and 4 by 3. Next term, listen my dear friends, R2 minus 2 into R1. R2 minus means 2 minus 2 into 1. Next term, 0 minus 2 into 1 by 3. The next one, minus 1 minus 2 into 4 by 3. So 2 minus 2, 0. Next one, 0 minus 2 by 3 means minus 2 by 3. Next term, minus 1 minus 8 by 3. Therefore, minus 1 minus 8 by 3 means minus 1 into 3 means minus 3 minus 8 divided by 3. So answer will be minus 11 by 3. Okay, just check it. So minus 11 by 3. It's correct. What is the answer actual value? Minus 11 by 3. Next term, third row. R3 gives R3 minus 5 into R1. That means 5 minus 5 into 1. Next term, 2 minus 5 into 1 by 3. Last term, 1 minus 5 into 4 by 3. So 5 minus 5, 0. 2 minus 5 by 3. So 2 minus 5 by 3 means 2 into 3 is 6. 6 minus 5 by 3 is equal to 1 by 3. This is actually 1 by 3. Last term, 1 minus 20 by 3, because 5 into 4 by 3 means 1 minus 20 by 3. Cross multiply 3 minus 20 by 3 is equal to minus 17 by 3. This is actually minus 17 by 3. Okay. Now the diagonal term, here we need to 1. What we have to do, into 3 means automatically 1 will come, isn't it? So what we have to do, R2 gives R2 into 3. R2 into 3. So R1, R3 as it is 1, 1 by 3, then 4 by 3. R3 also as it is 0, 1 by 3, minus 17 by 3. Into 3 means there is 0, then 3, 3 cancel. Again 3, 3 cancel, there is actually minus 11. Then there is actually after into 3, then each and every time divided by 2, because there is actually positive 1 we need. Okay, then what we have to do, R2 gives R2 divided by minus 2. R2 divided by minus 2 means R1 1, 1 by 3 and 4 by 3. R3 0, 1 by 3 minus 17 by 3. Then 0 minus 2 divided by minus 2, positive 1. Minus 11 by 2 means definitely minus cancel, only 11 by 2 will come, isn't it? 11 by 2. The next one, second columns, the first and the third element we have to show 0. What we have to do? 1 by 3 and 1 by 3 is there, isn't it? Each and every time 1 by 3 is there. So 1 by 1 we have to minus. So first time actually R1 compare R1 minus 1 by 2 into R2, isn't it? We need, there is 0. What we have to do? R1 gives R1 minus 1 by 3 into R1. Next time R3 gives R3 minus 1 by 3 into R3. There is R2, okay. Now we can check it. R1, R2 only, no need to change. R2 as it is 0, 1, 1 by 2. Listen my dear friends, okay. R1, R3, how to change out now? The first condition. So R1 minus R1 is equal to continue பண்ணலாம் வேண்டாம்ல ஸ்டாப் பண்ணிரும் next classல continue பண்றேன். Okay dear, so I will continue the same question next session. Okay, so okay, thanks to viewers. Again I am telling you, if you need more information, please subscribe our school channel. You will get it whenever we post a new video. You will receive the notification. So please give me your valuable feedback. We are ready to rectify as mistake if we did. Okay, thanks to viewers. We will continue our next session. Bye bye.